We're live and recording, so we'll go ahead and start. Good morning, everyone. Appreciate everybody joining us again for VC Ag today. It's Thursday, April the 22nd, 2021. Very timely topic this morning as producers are going to the field for burn down applications, pre-plant applications, and we're pleased to be joined by Mr. Doug Horn, an A&R extension agent out in Augusta County. Doug has done quite a bit of work with the Biological Systems Engineering Department on campus. And Doug's going to talk to us about understanding spray water chemistry. There is some testing opportunity, and Doug's been a part of that. But basically, he's just going to give us some information. If you've had a herbicide application before and it didn't seem very effective, you didn't get the results you were looking for, it may be a result of your spray water chemistry and where you're getting your mixing water from and its chemical properties. So really excited to have Doug join us this morning and share this information. Just a few housekeeping notes that we always mention before we get started. If you would, throughout the presentation, just try to remain muted so we don't have any background noise or disruptions during the presentation. Also, if you have questions or comments, we'll definitely get those addressed. If you could put them into the chat window at the bottom of your screen on the toolbar, or just hold those until the end. We'll open it up for questions and conversation at the end of the presentation this morning. And then finally, as I mentioned, the presentation is being recorded. So if you have folks, producers in your counties, fellow producers that you are in the same neighborhood or county with that may find this information beneficial, please direct them to that link there on your screen for the recordings they can find this week, as well as any other previous sessions of VC Ag today. So without further ado, Doug, we appreciate you joining us this morning, and thank you.
Okay, thanks, Robbie. Is my screen up or do I have to reshare?
You have to reshare, I believe, Doug. I still see the opening slide from Stephanie.
Okay. Got the right screen there?
Yes, sir. Perfect.
Okay, thanks a lot. We'll jump right in. My interest was piqued on this topic several years ago. I was reading an article in No-Till Farmer magazine, and it was titled, "Why Your Glyphosate May Not Be Working." And the byline says, hard water in the spray tank can cause double-digit reductions in the effectiveness of glyphosate applications and may also silently exacerbating problems with herbicide resistance in weeds. So I started doing a little bit of research and reading articles, and there's a lot of information out there. And I came across a presentation from an agent in University of Idaho, Rhonda Hernick, that she had done a pretty good job of summarizing the literature. So I used I'm going to use a lot of her slides in the presentation, and she gave me her blessings to go ahead and use them. So some of the common complaints, as Robbie alluded to, that might indicate you have a water problem is you hear comments like the pesticide doesn't have any residual. I need to reapply it every week. The pesticide doesn't work at the labeled rates. I need to double or triple the rates. The pests are resistant to the pesticide, or it just plain doesn't work. Some of the water parameters which can affect the pesticide performance include pH, dissolved minerals or the hardness, suspended solids, which they call turbidity, or the water temperature. So the literature indicates that some of the potential red flags for water quality are pH greater than 7 and a hardness greater than 150 parts per million, or bicarbonate levels greater than 500 parts per million. A lot of the pesticides are weak acids, so they're weakly acidic, and they work best at a pH of 4 to 6.5. You'll see through the presentation, those numbers, the range varies a little bit on each end, but pretty much in that slightly acid range for the weak acid herbicides and pesticides. So what happens when you put them in alkaline water, they can start to degrade. Sometimes they'll dissociate into simpler units, And if the pesticide has to be as a complete unit to be effective, then of course you're losing activity. Another thing that can happen is the molecule can change to the point that it is not absorbed by the pest, or it can form an inert compound and has no pesticidal activity. So the pesticide dissociation is when the complex molecule breaks down into the simpler units. Usually if this happens, you get reduced efficacy. And again, there's that pH range of 4 to 7 for your weak acid pesticides. The example at the bottom is with one of the 2,4-D amines. You can see the complete molecule on the left, and in high pH water, it will dissociate, and then you have the anion and cation. And if it's a molecule that only works as a complete molecule, then you can see you're going to lose activity. The other thing that happens is if you have minerals in the water, then they can associate with that anion, and you're working with different molecules. Some examples of the weak acid herbicides, you can see some of the commonly used ones there, the 2,4-D amine and atrazine, the dicambas. Glyphosate is a big one. It's very sensitive to pH and hardness in the water. Also want to point out that these chemical processes don't only affect herbicides. Fungicides and insecticides can also be affected in the same way. So with hard water, it can reduce the effectiveness when the pH gets out of the acceptable range. And as I said, it can dissociate into the anion and cation. And if you have a lot of total dissolved solids, particularly the hard mineral cations, they can react with the pesticide. And the typical activity is it won't be absorbed, or the rate of absorption is slower, or it can actually form new compounds which do not have herbicidal activity or pesticidal activity. An example from DuPont where they treated foxtail in a lab setting. You can see on the left, you have the untreated plant. In the middle, there was glyphosate. It was probably in deionized water, so there was no mineral interaction. And then on the right, it says the glyphosate plus calcium chloride. They added known concentrations of calcium chloride. And in the header, you can see this particular example was 2,500 parts per million calcium carbonate. We don't see those levels around here, but they do make the note that the same response was seen at 200 parts per million, which is observed in Virginia. So at that level, there was almost no activity from the glyphosate. It was all bound up by the water chemistry. Another example with velvet leaf. Again, on the left, you can see glyphosate in deionized water, so there should be no minerals present to react with it. Then you have the untreated plant in the middle, and on the right was glyphosate with well water. So you can see a little bit of activity, but greatly reduced where you're using direct well water. The thing that concerned me in this picture is glyphosate alone was not giving that great of a control. And so what's happening with velvet leaf, lamb's quarter, and sunflowers in particular, there's a lot of calcium on the leaf surface. And when the herbicide hits the leaf surface, it begins reacting with the calcium the same as it would in the water. And that can reduce the effectiveness on those particular weeds. So the University of California at Davis, one of the researchers came up with this general guideline, which you'll see quite a bit. It says a pH between 3.5 and 6 is satisfactory for spraying most weak acid herbicides. And it says short-term storage. So they're saying 12 to 24 hours. The longer a material sits in the tank, the more opportunity there is for the water to interact and reduce the activity. An important footnote is these concepts are not applicable to sulfonylurea herbicides. They are weak alkaline herbicides, and just the opposite is true. So a pH between 6 and 7 is adequate for immediate spraying of most of these weak acid herbicides. Again, they caution do not leave the mixture in the tank for more than 1 to 2 hours, or you can start getting reactions that's going to reduce the effectiveness. And if your pH is 7 or higher, then you should be adding a buffer or an acidifier to make sure you get good herbicidal activity. There's 2 classes of adjuvants that can be used to lower the pH of the water. One is simply an acidifier. That would be your acids like sulfuric acid or phosphoric acid. But they're very effective at lowering the pH, but any other additions, the pH can change and can move around on you. Other products are actually buffers that will stabilize the pH at an intended level. So they'll, if you're shooting for a pH of 5, a buffer will try to keep that solution around the pH of 5, which is a little more predictable. I do want to make the comment that you'll notice dicamba was on our list of weak acid herbicides. With the new low volatile dicamba formulations, particularly XtendiMax and Ingenia, you do not want to lower the pH of the water with those formulations, because you actually increase the volatility, and that's the whole goal of those products. I haven't studied the newer labels in a lot of detail, but when they first came out with them last fall, there's a very specific list of water conditioners and adjuvants that you must use in association with those products. I've alluded to the hardness, and hardness is a subset of total dissolved solids. So the total dissolved solids is all the minerals in the water. It's cations, anions, everything, and it's usually presented as milligrams per liter, which is the same as 1 part per million. The hardness is simply the calcium and magnesium concentration in the water. And as mentioned earlier, if the hardness is greater than 150 parts per million, it can be a red flag for your water chemistry. So a lot of times, as illustrated earlier, the pH and hardness work hand in hand to reduce the efficacy of the pesticides. And that's done because if the molecules dissociate at the higher pH, and then you have the hard minerals in the water, then they start binding with your pesticide. So I need to make a comment about the weak alkalines. They are just the opposite, where whenever the pH drops below 7, they begin to dissociate and you can lose activity. So most notable, the sulfonylureas. This is an older slide. You can see some names on there that are a little bit different now. But if you're using these herbicides, you want to have a pH greater than 7. Other ones to note is your copper-based fungicides or lime sulfur. You need to keep them in a alkaline water. So usually pH 7 or greater. The group 14 herbicides also tend to fall into this group. As Robbie mentioned, I've been doing some water testing in the Shenandoah Valley for the last 3 years. And I knew from our residential drinking water programs that the water in the valley, it's coming from limestone aquifers, and the pH almost always runs above 7, and our hardness is almost always above 150 parts per million. So that was the other reason I had a particular interest in this topic. So working with the Biological Systems Engineering Lab, we put together this report where we'll look at the minerals that tend to react with the herbicides. So we call that the pesticide performance group. And since they're running the minerals anyway, we said, well, shoot, if we just include some of the other parameters, this report would be good for people assessing the quality of their irrigation water. But the last part of the chart there, the AMS rate, that's the ammonium sulfate, is a very common water conditioner that avoids a lot of problems with water chemistry. So I'll just focus in on that. The researchers at North Dakota State University came up with this chart table that you can calculate the contribution of the different cations to their ability to react with the pesticides. So this is an example of Shenandoah Valley water. You can see the ones of interest. The iron is very influential in binding with herbicides, pesticides, followed by magnesium, then calcium. You can see the conversion factors gets smaller with the single charge cations. So when you sum all that up, in this example, it's saying you need 0.97 pounds of ammonium sulfate per 100 gallons to negate these elements in the water. Some of the common misconceptions for how to correct the problem with your water is just to add more water. I have an example in a minute that shows how when you add more water, you're actually putting more calcium and minerals into the system, which is going to tie up more herbicide. You can change the nozzles to get finer droplets. Well, it has nothing to do with the physical parameters of the spray. It's the reaction with the water. So as soon as you put that herbicide into water that has some of these issues, the herbicide is going to start losing effectiveness. And again, buying a new sprayer isn't going to help anything because it's the herbicide reacting with the water. One thing I did see pointed out is if you are using an induction tank in your with your sprayer, make sure you're using conditioned water through the induction tank, because if you're plumbed straight to the well water source, the reaction takes place almost immediately in some cases. So you could be tying up your pesticide before it ever gets to the main tank if you're using the raw water in your induction tank. So this is the example I was talking about with one of the water samples from Shenandoah Valley that had 393 parts per million of hardness. The UAP literature had a formula that would calculate the amount of glyphosate complexed at differing levels of water hardness. So in this example, they're only using 1 pint per acre of glyphosate in 10 gallons of water. And with that 393 part per million hardness, about 15% of your glyphosate was being complexed. So if you double the rate of water, go to your 20 gallons per acre, you're doubling the amount of glyphosate complex, because you have a finite amount of glyphosate, and then the calcium in the water is going to react with it. You add more water, you're adding more calcium, therefore you're going to tie up more of the given amount of glyphosate. So if you double the rate of glyphosate, the percentage is less, but you're still binding the same number of molecules. So, and again, the same relationship, if you double the amount of water, you're doubling the amount that is complexed. So some of the potential solutions for water issues would be a reverse osmosis unit. It does a great job of pulling the minerals out of the water, but it does not affect the pH of the water. And it's a very expensive option for an agricultural situation, especially if you're just doing your own acreage. Add ammonium sulfate. It is a very effective water conditioner. When you use the ammonium sulfate, you want to make sure that you put it in the tank first. You want it to react with the water so that when you add your pesticides, you don't have raw well water to react with it. You want to make sure you thoroughly agitate it. The literature indicates that ammonium sulfate works really good for calcium, and there's some question as to how effective it is when you're looking at some of the other cations. There are ammonium sulfate alternative water conditioners available. Some of them are using polymers and have different additives so that you can get by with a little bit lower rates. A lot of them have added surfactants or adjuvants that affect the chemistry of the water in addition to just working on the minerals. A lot of them will adjust the pH of the water and be buffered. And there is some evidence that just using plant oil-based adjuvants can decrease the water effect on pesticides. They think that oil is helping attracted to the pesticide and keeps the water elements from reacting with it. So based on all this stuff I read, I kind of came up with this list of recommendations. You want to definitely read the pesticide product labels, see if they have a range of parameters for your water quality. Choose a water conditioning product that will be effective on the conditions that you're faced with your water. Look over that label, make sure it's compatible with your pesticides, and then try to determine what rate you should be using. Add the water conditioner to the spray tank. And I say 2/3 to 3/4 full. A lot of the labels say put in half the water, put the pesticides, and put the other half. But since the water has the potential to react with the pesticide, the more water you have conditioned before you add the pesticide, the better it will be. And the less you have to add after putting the pesticide, it will reduce the reaction with the pesticide. So you definitely want to make sure you agitate and get a good mix. And you should let the conditioner react with the water as long as possible. So if you're using a nurse tank or a holding tank, then you would want to treat that holding tank. Then you would add the pesticides in your recommended order of mixing. Again, point out that you should use conditioned water through the inductor. Apply the spray mixture as soon as possible after mixing. Again, don't let it sit around. There's times when you can't help it, but don't deliberately mix the night before and plan to go out early the next morning. It can be working against you. I was afraid that train would come by. Hopefully it doesn't disrupt us too much. And then use the lowest reasonable spray rate in the gallons per acre. So that goes back to the example. If a product is labeled for 15 to 25 gallons per acre and your equipment is set up and can handle the 15 gallons per acre, you would have less opportunity for herbicide interaction at those lower volumes of spray. I mentioned turbidity as one of the factors, and basically that's just the suspended solids in the water. And usually these are organic matter or soil. And some herbicides bind very strongly to that type of material. So the chemists have a coefficient they call the soil absorption coefficient. Basically, the higher the number, the more likely the pesticide is influenced by solids in the water. You can see glyphosate there at 24,000 is a very high number, so it is very sensitive to particulates in the water. Paraquats and diquat are even much higher. Some pesticides have numbers like 400. So these three products in particular are very sensitive to that. So how do you check it? The easiest way to do it is take a 5-gallon bucket, fill it with water, drop a quarter in it. And if you can see the quarter, then you're probably okay. If you cannot see that quarter, or especially if you can't read it, then your options would be to use a pesticide that has a lower absorption coefficient. Look for a different water source, or if that's your only option for water, then you should be looking at inline filters to remove those solids from the water. Again, just caution to read the pesticide label, see what they say about adding water conditioner. Some are very specific, others are very vague and do not even address the situation. And if you have questions, try to reach out to the manufacturer or check with the sales rep to get the information specific to your situation. I have been doing a little research on this. I put out some glyphosate a few weeks ago on some barley. The top photograph is glyphosate at 17 ounces per acre, 23 gallons of water per acre. It's just well water, no water conditioning. The center 6 feet is the plot. There's each side of the plot, there's 3 feet that was untreated. Then the lower photo is the same water, the same rates, just adding 1 quart of ammonium sulfate. And you can, hopefully it shows on your slides, but there is visually more discoloration just by adding the ammonium sulfate. So this is real, and it does show up in the water. And you may not see dramatic results every time, but if you're putting the herbicide or pesticide in there, you want to make sure you get the maximum effectiveness out of it. So that's pretty much the prepared information I have. Feel free to ask any questions or comments. I know my talk was geared toward the hard water with high pH, which is indicative of the valley. You can see sodium does contribute to pesticide performance. And as my understanding is, in your part of the state, that sodium and low pH can be as much of an issue as the high pH or hardness. So
All right, thanks, Doug. Appreciate you joining us and sharing the information. I see we got one question that's popped up in the chat. And the question is, will Virginia Tech run water tests and give recommendations to improve the water? So do you want to touch on that just a little bit, Doug, about the program that you've worked with there, and kind of a little bit about the details with that program?
yes, this is a newer project. We've been working on it for the last 3 years. The Valley has kind of been the pilot program for it. There was quite a bit of work done in the Virginia Beach area by the agents down there. They have developed the report that I shared with you earlier. it's up to the individual agents in an area if they want to participate or do an active program. I guess the thing is to reach out to your agents and identify the need, and then they can work with the biological systems engineering to coordinate the sampling and analysis. Excuse me. So our report is heavily based on the formula from North Dakota State that is giving you the amount of ammonium sulfate, since that's the most common conditioner. The pH, you can use vinegar or acetic acid, which is acetic acid, or citric acid, are very effective at lowering the pH. I think ammonia can be used to increase the pH. So yes, we do provide some guidance in those terms. The one thing that surprised me is a lot of the ammonium sulfate products recommend some rather high rates. They're at 2.5 to 5 gallons per 100 gallons of water, which is 8 to 17 pounds of ammonium sulfate per acre. I mean, per 100 gallons. And you can see in my examples that we only needed in the neighborhood of a pound per 100 gallons to negate the effect of the minerals in the water. So I hope that answered your question there. And we are working on some literature, and hopefully as more agents participate in these programs, we'll get a feel for what the water quality is running in specific areas, so that we could do more blanket type recommendations, but still offer detailed information for your individual situation.
Yeah, thanks, Stephanie and Laura. They have added some stuff in there about some regionalized programs this year where they'll be offered at in this area in the eastern part of the state, as well as in some other counties. So as Doug mentioned, if you're interested in that program, just reach out to your local extension agent. And if they're not hosting one in their county, there may be one in the adjacent county, or at least within a close proximity that you could participate in. Got another question, Doug. Would you recommend testing your spray water source frequently, or have you found that water quality changes much over time?
I think it's pretty commonly accepted that the water can change over time. And there's probably seasonal variations. A lot depends on your well and your water source. pH in particular, it will fluctuate. I think if you have alkaline water, it's probably going to be alkaline, but it might be 7.2 at one point and 7.7 at another. So there's seasonal variations, and then there's some variations over time. A lot depends on your well. If in the valley, we're using deep wells in limestone veins, so we don't see a whole lot of variation. Where if you're in a shallower aquifer that's more influenced by surface waters, then you could see a bigger change in the parameters. So as far as frequency, we're at the point that let's get the water tested initially. Let's start, and then I think it is good to periodically check it. What that frequency should be, I don't know. I don't know if it's necessary to do it every year, but I think it is good to get your baseline to start with, and then every now and then check and see how it's the consistency is holding over time.
All right, any other questions or comments for Doug this morning? Certainly, if you think of questions after the presentation, let us know, and we'd be happy to get those answered for you. Doug, we appreciate you joining us this morning. I know that this program is, as you said, is still kind of in its beginning stages, but I think it's got a lot of potential, and I think it would really be a great resource and service to growers that may be dealing with these issues. I know here, like you mentioned, in the eastern part of Virginia, at least here in Essex, most of our household water quality samples, I pulled a report for that. And I know Stephanie and Laura and some others as well, but we generally run on a low pH side and higher sodium levels. So we may be having some issues with some of those others that you mentioned, maybe some of those other ones that lower pH can have an effect on it.
Yeah, and that's the other thing too, I really didn't allude to, but it brings up the point of tank mixing. If you have a sulfonylurea and you're trying to mix it with one of these weak acid herbicides, what criteria is most important? And maybe if you can't find a conditioner that's at a happy medium, you may be better off avoiding that tank mix to optimize the response of each herbicide.
All right, I don't see anything else in the chat, Doug, so I'll just make a final call for any questions or comments for the presentation this morning. Really appreciate you joining us, Doug.
Thanks for the invitation. Enjoyed it.
All right, well, I don't hear anything else. So again, let's thank Doug Horn, Extension Agent in Augusta County, for his time and consideration this morning to share this update with us. We appreciate all your work, Doug, and thanks for kind of spearheading this effort and doing a lot of work with this testing program for herbicide compatibility and efficacy. So thank you again. You see on your screen there this morning, our next VC Ag Today presentation will be on Thursday, May the 6th. We're going to be joined by Dr. Katie Payne down at Southern Piedmont Research Station, and she's going to talk to us about growing award-winning hay. I know that there is a program for a competition throughout the Southeast that she's really endorsing and trying to get producers to get interested and participate in. We're also, at a time in the spring where fertility and a lot of management considerations to set ourselves up to make a good hay crop this summer. So if you are a forage producer or no forage producers that would be interested in that presentation, please encourage them to join us on Thursday, May the 6th at 9 a.m. As always, we'd also like to thank the agents that make the effort possible: Laura Maxine, Mike Broadus, Stephanie Rommel, Trent Jones, and Frank Long. So thank you to all the agents that make the effort possible. Again, the meeting has been recorded, so you can find the recording at the link there on your screen, and as well as all previous versions of VC Ag Today. And then, of course, finally, if you would take a few moments, as always, to fill out our evaluation for the program, let us know what you think, if it was helpful, if you have ideas for future topics, frequency, any of those things. We really would appreciate the feedback on that. So with that, I appreciate everyone joining us this morning. Laura, do you want to go ahead and take over now for your awards for the evaluation for Crops Conference?
All right, too many buttons. Couldn't even find the unmute. I am here. Can you guys see the, whoa, can you see probably my baby right now? Can you see the wheel?
Yes, ma'am.
Okay. All right, well, we did try to get Vanna White to do this, but she let me know that there was a pandemic going on. I don't understand why she's not with us today, but I'll do my best at doing the prize drawing for today. The names on the screen are the ones that participated in the evaluation for our Crops Conference. And all of the ones listed will receive at least a gift card and some great swag from, we have swag from Manel, a lot of swag from Manel. Farm Credit, we have some great swag from them. The Hanover Farm Bureau, they gave us some gift cards, and Riverland Insurers also some gift cards First Bank and Trust some $50 gift cards, so that's great. And we thank everyone for the gift cards. And then the Virginia Soybean Association, they gave us this really nice mug, which when it's turned to win that, if you ask my husband, I collect these things. I love these, so I'll hate to see this go. I didn't use it though. And Three Rivers Soil and Water, they gave us some gift cards. So we will start. So this is a randomized drawing. Let me first say that Ray H won. He was the first one that participated in our evaluation, and we only had to ask him once. He was the only one with the initial request to fill out the evaluation. So he gets a $50 gift card and an extension gift pack, a Manel hat. He gets the granddaddy of all prizes for being the first person. So that's Ray H. And then we'll start with the drawing. So these are all randomized as to who will win what. Hunter G, you won a hat, a $50 gift card to Outback from First Bank and Trust, and a notebook from Manel. So some great prizes there. We'll remove your name and do the drawing again. Larry H, this is a bag from Manel. It's got some golf supplies. I hope you're a golfer. It's got a great mug from them, and of course a gift card to Tractor Supply. So congratulations. The next prize we're going to do is another extension gift bag and a $25 Amazon gift card. All right, Kathy, woo! Remove your name. And the next is going to be the coveted mug of Laura. This is from the Soybean Association. There's all kinds of goodies in there, some hand sanitizer, some chapstick, and a $25 gift card to Tractor Supply. Mhm. All right, Clayton, I'll find your name on here so I don't get things mixed up. Mhm. The next is a Manel hat. Again, everyone's getting a hat, a Manel coffee mug, and a $25 gift card to Tractor Supply is also in here. Kimber. All right. Ooh. It was a hat, a gift card, and a rain gauge. All right. So the rest of the individuals that are listed, we have a hat and a $25 gift card for you. So as promised, everyone who participated and took the evaluation and attended our crops conference and then did the evaluation won at least a gift card and a hat. So thank you all for doing that. We really appreciate the feedback. And just because we have done the evaluation doesn't mean we have to stop there. You guys, please attend that virtual conference that the specialists put on for us and that we house through VC Ag Today, and join us for future VC Ag Todays and fill out those evaluations because we really appreciate it. I think that's it for me, Robbie. Oh, yes. And of course, thank you to our sponsors. I always forget the sponsors. I have it up here so I don't forget. But thank you to our sponsors. And I can't get that up right, but there it is. All right, anything else, other agents? So thank you again, sponsors, and thank you for filling out those evaluations.
All right, thanks, Laura. Appreciate everybody's efforts to fill out the evaluations. Again, thank you to all the sponsors listed there on the screen. We appreciate all of your support. These programs would be very difficult, if not impossible, to provide without our sponsors. So thank you very much for all your support. Thank you to the participants as well. With that'll conclude today's VC Ag Today program, and we hope everyone has a great rest of their Thursday and stays safe.